Hello everyone. This is the second to the last video that focuses on the linear inequalities. But then again, we are still on absolute value linear inequalities. In the previous two videos, we're able to present our absolute value linear inequalities into the linear inequality form following the general forms, specific general forms for less than and then the greater than symbols. And then we're able to come up with this equivalent solution sets, the equivalent graph, and equivalent interval notations. As for this practice exercise, we are still going to do that. As instructed here, we are going to solve, give the linear inequality form, and then give the equivalent solution set, graph, and interval notation of the solutions. So we are under less than for all of these items here. So we are going to follow the concept that if it's less than any constant c, we just simply take the value or the expression inside the absolute value notation, which is actually be greater than the negative of that constant, but less than of that constant. Okay. So yeah, let's apply it for number one. In number one, our quantity here inside the absolute value notation is 6x. So do not just simply say x and then blah, 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 and then blah, blah, blah. We are lucky in the previous videos that we only have the variable here inside our absolute value notation. But since we do have here a numerical coefficient the same with 1 or not equal to 1, we are going to take the whole quantity. That would mean 6x is greater than the negative of 120 but less than positive of 120. That is the application of the general form following the concept that it should be the whole quantity of the absolute value notation, not just the variable itself. Take note of that. So we have this expression right now. In the previous video, especially specifically in practice exercise A, as soon as we apply the general form, that's it. We are okay already with that. But since here our general form should only have x, but we have 6 here in the middle. This means we need to remove here the 6 by, since 6 and x is under multiplication, let's divide it by 6 to cancel that out. And making sure that the notation or expression rather in the middle of our linear inequality form is just x, which would actually be similar to our general form now. But of course, we also have our properties of inequality that whatever we do on one side, we don't do it also on the other side. But since we have three sides here, the middle, the left, and the right, we apply the same thing through all. So when we divide here by 6, we also divide here by 6, and also here. That should be what must be applied to restore, or not necessarily restore, to retain, yes, to retain the inequality. So with that, we'll have here x is greater than negative 120 divided by 6 is negative 20, but less than 120 divided by 6 is positive 20. Okay. Because if you're going to stick with what you have here earlier, let's say less than 120, you could actually try 100. Yeah, it's less than 120. But when you substitute 100 here, 6 times x, which is 100, is 600. Absolute value of 600 is positive 600. But it's not less than 120. Why we actually made a mistake there if we are going to retain here or stop here, because we have not applied the division of 6. That would mean when we divide by 6, the maximum integer here, integer, again I repeat integer, is 19, right? You could also have 19.5, 0.4, etc., etc., but the maximum integer is 19. If we're going to try 19 here, 6 times 19 is more or less what? 6 times 19 is 54, plus 60 is 114, right? So again, 6 times 19 is 114. And the absolute value of 114 is less than 120. And that would mean it's not acceptable after we reach here. And this is how actually the correct linear inequality form. I'm just making a emphasis right now. So our next one is, now that we are sure of this, we can come up with our solution set. and then graph and interval notation, following the concept discussed in the practice exercise A. You might want to check that previous video. So here you can simply have x such that copy x is greater than negative 20, but less than positive 20, and close it. Okay. As for our graph, since it's less than, we already have the idea and analyze that the graph should be meeting between two different endpoints. And the endpoints we're talking here are the values for our constants in the leftmost and the rightmost side. So we have here the values of negative 20 and the positive 20. And we have the values in between. So all values in between. Yan. Yan. And then, since negative 20 and 20 are not included because we don't have equality signs here, and even if you're going to substitute here, let's say 20, 6 times 20 is 120. Absolute value of 120 is still 120, but it's not less than the value here, which is 120. I've been repeating 120, yeah? Please follow lang po. So that would mean it's really not included. So we are going to open this here as well as the negative 20 on the other side. So as we open them, open and open here, we should also end it by adding parentheses. All right, that completes our graph. They meet in between. And our interval notation shall only cover this region. So you have negative 20 until 20. They are not, both of them are not included. And when you look at the graph, we use parentheses as well. Okay, and that's for our number one. Again, what is different from between number one from the previous practice exercise A is that we have applied here division of coefficients in all sides. In item number two, we will not be dividing. Okay, let's look at this one. By applying the general form, we'll have the quantity, again, not just x, not just 6, but it should be the binomial x minus 6 is greater than negative 3. That's negative, sorry, negative 3, but less than positive 3. Right. Do not be do not assume that we could divide this because you divide here at the top, you will also divide here. No po. Look at the value of 6 here. This is negative 6, not a coefficient of x, but it's a constant. That's why we have a binomial here. So instead of dividing that by 6, we could actually add 6 here. And then what we added here, do the same in this area, do the same in this area. By the way, I am doing the vertical method, but if you would like to use the horizontal method, just like this, it's still okay. I'm just going to use vertical method because of the spaces. Nevertheless, they're just the same. So that becomes 0 already. We'll have here x is greater than negative 3 plus 6. Please check your integers. That's actually positive 3. And then we have about less than 3 plus 6 is positive 9. All right. So we're not yet sure. Pick a number in between. We cannot use 0 here because the smallest value should be greater than 3. That is actually be 3.00001 and so on and so forth. But we could pick here 4. So 4 minus 6 is negative 2. The absolute value of negative 2 is positive 2, which is greater than 3. Correct. The next one here is probably in this area. You can use 8 or any other fractional numbers, but let's just simply use 8. 8 minus 6 is positive 2. Absolute value of positive 2 is still 2. And that is still less than positive 3. This would mean this is already acceptable. And we are now ready to come up with our solution set. It should be the set of x such that you copy. X is greater than 3, but less than 9. And close it. That would be our solution set. So we had know already that our graph should be meeting in between using these endpoints here. The endpoints are based of this value here, 3 and 9. And then they should meet in between the two. All right. Sorry for the spill here. I'm just going to erase it later because we know that 3 is not included and 9 is not included as signaled by the symbol without equality. So erase. I have here erase as well. And then complete by A, adding by A parenthesis. Parenthesis as well. That's parenthesis. All right. That's our graph. In the interval notation, again, shall cover this. You have 3 to 9, parenthesis, parenthesis. You see, it goes easier if you have or familiarize rather, or if you were able to try it on your own, showing our solutions into different forms. If you have problems with that, again, review practice exercise in the previous video. In number 3, we might see here a combination of what we did in number 1 and in number 2. Because when we apply here the general form, we have the whole quantity here. You have 2x plus 5 is greater than or equal to the negative of 7, but less than or equal to positive 7. The first thing here is to remove make sure that the middlemost term expression will only contain x. So we could either remove 2 or 5 here. My suggestion is, of course, remove 5 first by subtracting 5 here, minus 5 here as well, and minus 5 here as well. And do have that's 0. We are left with 2x is greater than or equal to, that's negative 12, but less than or equal to, that's positive 2. Okay, that's positive 2. Then we'll now remove 2 by dividing both sides, or all sides rather, by 2. Again, we have combined the process of removing here the constant, but first we added 6 here, the opposite is minus 5. And next step is copying the same process here as dividing by 6. But here we simply divide by 2. We could cancel that out. We do have x is greater than or equal to negative 12 divided by 2 is negative 6. And we have here equal to 1. Because again, if you are not going to divide this, that's a very problematic process now. So you could pick here values. I could choose 0, the easiest one. 2 times 0 is 0. Plus 5 is 5. The absolute value of 5 is still 5. And it's less than 7. That's correct. We should now accept this. You may use other values. Even 1 will do. 2 times 1 is 2 plus 5 is 7. Absolute value of 7 is 7, though it's not less than this value here. But since we have equality, 7 is equal to 7, acceptable. Also negative 6, you may want to try that. So to finish this, we have the 3 forms. First, the solution set of x such that x is greater than or equal to negative 6, but less than or equal to positive 1. Close it, right? And then next, our graph, we have the endpoints here. Do not use the values here po. We always use the linear inequality form. You have negative 6 until 1. All values in between. So let's shade it by red. I might not be able to shade everything here, so just bear with me. Negative 6, we have equality here. Okay, negative 6 times 2 is negative 12, plus 5 is negative 7. Absolute value of negative 7 is positive 7, though not less than this. Since we have equality here, 7 is equal to 7. That would mean negative 6 is included. We close it here. We already tried 1 earlier and we found out it's really included. Like that. Complete this by a bracket. And I would like to express that not all references uh, use rather brackets or parentheses as the further notation for inclusion or non-inclusion. But we are just going to add it here to come up with an easier interval notation, because our interval notation will either use brackets or parentheses. In this case, we'll have -6 and 1, and we'll use bracket, copying from the notation we used here. This is the complete solution for item number 3. So then again, we just simply added here the properties of inequality to come up this. Unlike the practice exercise A, that is just one application of the general form, we could automatically say that's the correct linear inequality form. Here, after application, you still need to use the properties of equality to make sure that the middlemost term will only contain x. Okay? So please continue reviewing this one. You may view and review this video as you prepare for our assessment soon. So please prepare and take rest, pahinga din po, and then you balance your time and study habits. Thank you very much. See you soon. Bye-bye.